Hello and welcome to another video. In this video we're going to be working on calculate money in a LeetCode bank. And in this problem, someone wants to save money for his first car. He puts money in a LeetCode bank every day. He puts $1 Monday, and then every day he will put $1 more. And then on every subsequent Monday he will put in more than the previous Monday, $1 more. Given and return the total amount of money he'll have in the LeetCode bank. So here we have 4 days, so you'll just put in 1, 2, 3, 4. 10 days, the first week, every day will increase, and then on the next Monday, it's going to go back to one more than the previous Monday. And then for a bunch of days, kind of the same thing, so every day increased by 1. Then on the start of the week, you drop down to 1 more than the previous Monday, then you increase every day, and then the same thing, you have 1 more than the previous Monday. So you could pretty easily make a simulation of this where you just loop n times and you figure out like, okay, for every day, let's just add 1. And then on every single Monday, let's subtract some number, and then you can get a total. So that's one way to do it. We're actually going to talk about the O1 solution, because it's a little bit more interesting. And yeah, it's a little harder to do, so we'll get into that. So there's a few things that we need to get the O1 solution. And the first thing is number of weeks that pass, right? Like full weeks. So the number of full weeks that pass. So like let's look at like maybe this third example. So the number of full weeks that pass if n equals 20, it's just going to be 2, right? Then the second thing we need is number of days left. And so for the number of days left, we need to figure out basically like how many days do we have left over is like the remainder after we did some full weeks. So in this case, we have 2 full weeks, so we have 6 days left. And then from there, the next thing we need to do is we need to figure out like how do we quickly calculate, like we know how many weeks passed. Is there a way we could just plug this into some math equation and get a result? And so notice for our actual, if you look at these sequences, so like let's look at the weeks, right? So for week 0, the sequence is 1, 2, 3, 4, 5, 6, 7. For week 1, it's 2, 3, 4, 5, 6, 7, 8. And then for week 2, it is 3, 4, 5, 6, 7, 8, 9. So notice for one thing, these are arithmetic sequences, right? They start at some number, and then they always increase by a constant amount. So let's take a look at the totals here. So actually for this total is 13, 18, 22 plus 6, so 28. This total is the same as the previous total, but since every number is 1 higher, it's going to be 28 plus 7, so 35. And this is going to be 42. So basically we can write this down for a week. So like week 0, week 1, week 2, week 3. Our actually total for an entire week is going to be like 28, 35, 42, 49, and so on. So if we have the number of weeks that we actually fully completed, like let's say we completed 2 weeks, in this case we did, we can just figure out exactly like what the total is for the 2 weeks, right? Because we know week 1 is going to take 28, week 2 is going to take 35. If we had some arbitrary week, we can just do that number, right? We can just do 28 plus 7 times like the number of weeks. So 7 times weeks. And we can figure out like how many weeks the last week took. So if 2 weeks passed, then week 2 at this index 1 is just going to be 28 plus 7 times 1. So we can figure out like how long did the last week take. So in this case, the last week was week 1, right? If the weeks are 0 indexed, let's just say, then week 1, week 0 took 28, week 1 took 35. So we can figure that out. So for example, if 10 weeks passed, then we would just calculate how long did week 9 take that's 0 indexed. So here, the first week always takes 28, or this 0 indexed week. We can also write it like this to make it a little bit less confusing. And then we can just change our formula a little bit slightly, right? So it'd be like week 1, week 2, week 3, week 4, something like this. So we could say, okay, week 2 would take 7 times week. Whatever week you're on, you can just do this if you want it to be 1 indexed. So this would also work, right? So if we're on week 2, we're gonna get 35. Week minus 1. So that's totally fine as well. Okay. And so now that we know that, what we really need is how to get a total. Like let's say we did some number of weeks. What we really need is what's the total that we actually got, right? Because this is per week, but really what we want is we want a total. So because this is an arithmetic sequence, it's actually pretty straightforward. And let's just like have some easier numbers just to see how we could easily do it. Let's say our sequence instead was like 2, 4, 6, 8, 10. And we're trying to get the average, right? The idea is, because this is an arithmetic sequence, it increases by the same amount. All we want to do is just get an average and then multiply that by the length of the sequence. So here, it's kind of pretty straightforward to get the average. The average would be the 6. So we can just say, okay, well, if the average is 6, then we'll multiply that by the length of the sequence, which is 5. So the sum of this sequence should just be 30. And if we look at it, so it's 18, 24, 30. And that's how you get the total of an arithmetic sequence quickly. It's just going to be first value plus last value over 2 to get the average. So we can call this also average over 2 times length of the sequence will be the sum. So we're not actually going to build the sequence, we're just going to figure it out and then get the sum. So in this case, let's plug in our numbers. So what's the average? The first number in the sequence is going to be 28. And the second number of the sequence, if 2 weeks pass, is going to be 28 plus 7 times weeks minus 1. So the last week that happened was week 2. So this would be 2 minus 1. So the last is going to be 35. So we just take the average of 28 and 35, and then we divide by 2. So we do 28 plus 35, divide by 2, and then we multiply that by the length of the sequence. The sequence is 2 weeks, so we just multiply by 2. And then the 2's cancel out, so we just get this as our total. So in this case, it's going to be 63. Yeah. Okay. And so that is our total for 2 weeks, right? So total for the 2 weeks. But now the thing is we also have days left over. Like in this case, we have days left over, right? We have 6 days left over. And so now we can kind of do the same thing for an arithmetic sequence, basically exactly the same thing. So if we have 6 days left over, how do we know what the numbers are for these 6 days? Well, we can just figure out what week we're on, right? So this is the last week here. So it should be 3, 4, 5, 6, 7, 8. So if we know we are on week 3 for these last 6 days, and we know every week we add 1. So because we're on week 3, we'd have added 1 twice, right? Because our numbers are like 1, 2, 3, 4, 5, 6, 7. Then week 2, we add 1. It's 2, 3, 4, 5, 6, 7, 8, like up here, and then so on. So when we're on week 3, if this was 1 indexed, if this was week 1, week 2, week 3, then basically the number we add is just going to be number to add is just weeks, or the week we're on, minus 1. Right? So in this case, because we're on week 3 for these last 6 days, for every single number, we will add 2. So the number for the first day of the days we have left is going to be 3. And then it's going to be like 4, 5, 6, and so on, right? So the number for the first day is going to be 3. And if we have 6 days left, we can just calculate like what's going to be the last day. So if you think about it, it's going to be like 3, 4, 5, 6, 7, 8. So the number for the last day is just the number for the first day. So we can write that down as well. Number for last day equals number for first day plus the number of days minus 1, right? So that's just like pretty straightforward. So the number of days here is 6. So the number for the last day would be 8. That's just like a basic, if your array increases by 1, like what's the index, like 6 indices ahead and so on, right? It's going to be whatever the first one was plus the length minus 1. And so now that we have the first and last day, we can do this like range again, right? Where we can take the average and then we can just multiply by the length. So let's get an average here and then multiply by the number of days. So in this case, we have 6 days. So then what it's going to be is it's going to be 11 times 3, which is 33. And if we write out our days again, so it's going to be like 3, 4, 5, 6, 7, 8. We do a total, we have 15, 21, 26, plus 7, which is 33. So basically you do this arithmetic sequence sum for the days and the weeks, And then you're able to get both of them in O of 1 because you know exactly, like, for the last week, you know exactly where the first day starts depending on the week, because every week you add 1. And then also for your sums, every week for the total week, you just add 7. So that's kind of how you do it. It's a pretty straightforward problem once you know that. And this is kind of useful to know how to get the sum of an arithmetic sequence, because now if you recognize you get something like this, you never actually have to build it. All you have to do is just get an average and just multiply it by the length of it. Okay, and now we can code it up. So I think this solution's closer to a medium problem. If you were asked to do this in O of 1, so I think the simulation is like pretty straightforward, so no real point in going over that one. Okay, so we're going to calculate our weeks. So we'll say full weeks equals n divided by 7. Then we have our days left over as the remainder, which is n mod 7. So let's say we have n is 20. Here we would have 2 full weeks, and then we would get 20 mod 7, which would be 6 days. Now we're just going to do this range sum thing for the weeks, and then we'll do the range sum for the days, and then we can just add those together. So you could say total full weeks equals full weeks times. So a lot of these things are going to add together. So basically, the first day is going to be 28, and the last day will be 28. Or sorry, not the first day. The first week will be, the sum will be 28, and then the last week it'll be 28 plus 7 times some number. So this is really going to be 56 plus, and then you add 7 full weeks minus 1 times for the last week. So get that, divide by 2. So this part gives you the average. This is the length of your actual thing. Okay. So the second part is going to be pretty similar, where we'll do this for the days left. So we'll say total days left equals days left is going to be the length of this arithmetic sequence. And then it's going to be kind of similar, where the number we start with for both of them will be full weeks. So it's going to be 2 times, because the number we start with for both of them will be 2, or full weeks plus 1. So for example, if our full weeks that we went through was 2, that means this first number of the days should just be 3, right? So it should be like 3, 4, 5, 6, 7, 8. So whatever full week we went through plus 1 will give us the starting number for both of them. And then for the last day, we also need to add what we need to add, right? So the last day is going to be days left minus 1 greater than the first day, right? So if you do this, the first day will be 2 plus 1, which is correct. And then the last day will be 2 plus 1 plus this days left, so that'll be 6 minus 1, which will be 8. So essentially, this part is going to be in both of them, and then this part is going to be in the second one. So 2 plus 1, 2 plus 1, and then this is in the second one. So you just combine terms here. Okay, and then we also need to get the average here. So we got the average, multiplied by the length of the sequence, and finally we just return both of these added together. So. And there we go. And so you could also do this. You could, for your days left, you could just do that in a loop, because you only have like 6 days or something. So you're still quite saving on constraints here, right? Because if this is 1,000, you could calculate your days left in a loop. But basically, you can do both of these in an arithmetic sum. So this would be like a true O of 1, I guess, solution. And yeah, I think this is like significantly faster than the other ones. And I'm sure, I guess we could, I don't need to do that actually. So yeah, so we can write down time here. And it's just gonna be O1 and space is O1. And also another thing I noticed, I don't know if you guys noticed, I think they added a new feature of LeetCode, I don't know when. So you can actually like click on solutions now, and it will literally tell you like, here's what the solution that got this was. So kind of useful as well. So you could see okay, so funnily enough, here they actually didn't do the arithmetic sum, and it's actually faster than, this is why the LeetCode solutions don't make sense, because here they didn't do the arithmetic sum, they actually loop through the number of weeks, and this ends up being faster. So for these small runtimes, this stuff isn't super accurate, which is kind of hilarious. Like a slower runtime solution actually a bigger time complexity actually runs faster. that's why I said when you get these solutions, like don't really worry about what numbers you get. Worry more about like theoretical time complexity. Because I had plenty of solutions that I wrote that are like that I wrote in O of n, but then like my n log n answer was like significantly faster somehow. So, yeah, so that's gonna be all for this one. So if you liked it, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.